Okay, so we're going to be talking about day 3, real zeros of polynomial functions today. So the first thing we're going to look at is types of division. So we have long division and we have synthetic division. And these are techniques that can help us be able to find rational zeros when we're looking at polynomial functions. So first we're going to review how to use long division. So what you're going to do for long division, first off you're going to make sure you're not missing any terms. So what I mean by that, see how we jumped from x cubed to negative 3x here? So we're missing that x squared. So if you're missing a term, you need to make sure you put a 0 with it. Here we have x and we have a number, so we're not missing any terms there. So when we set up our long division, we're going to have this x plus 2 on the outside. And then on the inside, we're going to put x cubed plus 0x squared minus 3x plus 4. Alright, so your first step for division is to divide. So you're going to divide your first term divided by your first term. So I'm dividing x cubed divided by x, which will leave us with x squared. So when you do this, you're going to make sure you line it up. So this is x squared here, so we're going to put this x squared on top. After you divide, you're going to multiply. So we're going to do x squared times x, which will give me x cubed, and x squared times 2, which will give me 2x squared. After that, you're going to draw the line and change the sign. So this becomes a negative, this becomes a negative. Your first term should always cancel. So x cubed minus x cubed does cancel. So we have 0x squared minus 2x squared, which will leave us with negative 2x squared. And then we're going to bring down the next term. Once you've done that, you're going to start all over. So we're going to start over, and we're going to divide the first term divided by the first term. So first term divided by first term. So negative 2x squared divided by x, which will give us negative 2x. So we're going to line that up on top, put negative 2x here. After you divide, you're going to multiply. Negative 2x times x will give us negative 2x squared. And negative 2x times 2 will give us negative 4x. So we're going to draw the line and change the signs. So negative 2x squared and positive 2x squared will cancel. Negative 3x plus 4x will give us x. And then we're going to bring down the next term. That's our last term to bring down, so this will be our last round that we have to do. So then we're going to divide first term, which is x, divided by first term, which is x. So x divided by x will give us 1. Okay, so we're going to put plus 1 on top. Then we're going to multiply. 1 times x is x. 1 times 2 is 2. Then we're going to draw the line, change the signs. X minus x will cancel, and 4 minus 2 will give us 2. So this 2 is our remainder. And to write our answer, you're going to write out what you got in the top part here. So we have x squared minus 2x plus 1 plus the remainder, which is 2, over the part that's on the outside here, the x plus 2. So that's how you're going to write your answer. So that is an example of long division. Okay. So next we're going to take a look at synthetic division. So synthetic division you can only use whenever you're dividing by a binomial, and the binomial has to just have x. So it's going to be x plus something or x minus something. You do want to make sure you're not missing any terms. So we're not missing anything here, but here if you see we're missing the x cubed, so we got to add in that 0x cubed. So for synthetic division, you're going to draw this little chart, this L-shaped chart. On this ledge here, you're going to solve this for x. So x equals 1, and that's what you're going to put on the ledge. Over here, you're only putting coefficients. So you're making sure these are in order. You're only putting the coefficient. So it says 2x to the 4th, you're just going to put a 2. 0x cubed, you're going to put a 0. 3x squared, 3. Negative 1, positive 1. So to do synthetic division, you're going to bring down your first term, which is 2. And then you're going to multiply. So 2 times 1 gives you 2, and you're going to add down the column. 0 plus 2 is 2. And you're going to multiply 2 times what's on the ledge, 1, which gives us 2. Add down the column, which gives us 5. Then multiply 5 times 1, which gives us 5. Add down the column, which gives us 4. 4 times 1, which gives us 4. Add down the column, which gives us 5. The last number is always your remainder. So we have a remainder of 5 here. So when you're writing this out, if you started with 2x to the 4th, you're going to go down 1. So we're going to really start with x cubed. So the first term is going to be 2x cubed. The next term is going to be with x squared, so 2x squared. Next term is just going to be with x, so 5x, plus 4, coefficient by itself, and then we do have that remainder of 5 that you have to put over the x minus 1. So that was using synthetic division instead of long division there. Okay, the next thing we're going to talk about is the remainder theorem. So the remainder theorem says if a polynomial f of x is divided by x minus k, then the remainder is f of k. So this is saying we can find the remainder by just doing f of k. So if they give you f of x here and they ask you for the remainder, you could do long division, you could do synthetic division, but a shortcut here, or a way that you could find this without having to actually divide, is whatever this is. So if this binomial says x minus 2, you want to solve it for x, so we're going to use x equals 2. It's saying if you find f of 2, so if you plug in 2 everywhere there's an x, that will tell you the remainder. So let's go ahead and do that, and then we'll check and see, make sure that's true. Okay, so if we simplify this out, we'll have 16 minus 12 plus 8 minus 7. So that will give us 5. So this means that 5 would be the remainder here. Okay, so once again, instead of us just dividing, or synthetic or long division, it says to get the remainder, if you plug in what this x value is for x here, it'll tell you the remainder. So let's check and see if that's true. Let's use synthetic division to check. So x minus 2, so you would put 2 on the ledge. No terms are missing. So bring down your first term. 2 times 2 is 4. Add down the row. 1 times 2 is 2. Add down the row 6. 6 times 2 is 12. Well, that is a remainder of 5, so that is true. So this is just the remainder theorem. Gives you an easier way to find the remainder without having to actually do the division. So this one says, what is the remainder of f of x when we divide by x plus 4? So we're talking about an x value of negative 4. So we can get the remainder by just plugging in that negative 4. And you could use a calculator to figure this out, but when you figure it out, you get negative 3,839. So that would be your remainder. Okay, and you could always check that using long division or synthetic division. Alright, so next we're going to talk about the factor theorem. So the factor theorem goes right along with the remainder theorem. The factor says a polynomial f of x has x minus k is a factor if and only if f of k equals 0. In other words, if and only if the remainder equals 0. So a factor just means that it goes into it perfectly. So it's saying it goes into it perfectly with nothing left over, no remainder. So we're trying to use the factor theorem to determine if x minus 3, so in other words x equals 3, is a factor of this f of x. So all we care about is the remainder. So we can use that remainder theorem that we just did. We can plug in this 3 here. So if we plug in, so that does give us 0. So 0 here is the remainder. Well, if the remainder is 0, that means it goes into it perfectly. So we can say here, x minus 3 is a factor of f of x. Okay, we also could have figured this out using synthetic division or long division. We would have just ended up with a remainder of 0. But anytime you have a remainder of 0, that means that you have your binomial there is a factor. So that x minus 3 is a factor here.